Now that we've created the base part, we've created the bottom cap and the top cap, we're going to bring that into an assembly. And once we've got it in place in the assembly, we're then going to go through and make an in-context part for the body. What that's going to do is use all the geometry from the bottom cap or the top cap, whichever one we happen to use, and it's going to create a new part. So all the parts will be associative, okay, so meaning they're referenced off other geometry. Let's just go and click on the assembly button. Now assembly is just, it's a bit like a part file, but it's where we bring all the components in and we can start to put things together. Has a lot more functionality in terms of, we can bring in parts from the content center, which is a library of nuts and bolts and bearings and all that sort of stuff. We can generate gears and do bolted connections and all sorts of stuff in here. So it's quite powerful. But for what we're going to do, we'll keep it simple. So the very first thing that you need to do in here is, again, best practice, just come over to your origin and expand the origin out. You'll see you've got your XY planes and all that sort of stuff. Okay, so just indicating, yeah, everything that we're going to be working with. So when we bring these parts in there, what we want to do is constrain the X, Y, and Z planes with the XYZ planes in the actual assembly. Now we only need to do one part just to fix it into location, then everything else we can constrain to that. Right. Up the top here where you've got place content center, just click the little pull down and we're going to use just place. And because we're still in our project file, you can see our parts. So the first thing I'm going to do is bring in the bottom cap. So I'll just click bottom cap and open, and you can see we can just plonk that anywhere. So just click, right click, OK. And before, I'm not going to bring in the top cap yet. I just want to get this one fixed in location. So one thing to look at is just have a look at your view cube just up the top here. You can see that's the front, the bottom, right, left, top, and all that sort of stuff. So you want to orientate your model into the views that you want. All right, so the very first thing I want to do is looking at my part here. Let's expand the part out. And you'll see there's the origin. Let's expand the origin out. And you've got the X, Y, and Z planes for the part, and then we've also got the ones for the assembly. So we want to match these up. So you can see if I pop that there, there's my assembly ones, and here's my part ones. So the first thing I'm going to do is I'm just going to align the bottom edge of this, which happens to be my XY plane, with the XY plane in the assembly. To do that, we click on the constrain button up here. And under constraints, you'll see we've got under assembly, you've got a mate. So a mate is just going to give you this one in here lines two surfaces together, or two faces that are opposing. This one here is still a mate, but it's a flush mate. So when you've got two parts that you want to be flush, you can use that one. We then pop over to here where we've got angle, tangent, insert, and symmetry. We'll look at those a bit later on. And once we get into other assemblies, we're going to start playing with motion and a few other bits and pieces. So I'm just going to get rid of this for now, because you don't need to know that. That will come into play later on. Just using your standard mate, what we're going to do is come down into your model tree, and we're just going to click on the XY plane of the part, and we want to mate that with the XY plane on the assembly. So I click on that. Now when that does that, you'll see it's flipped around and it's gone upside down. Okay, so that means I want to use a flush mate. So if I click flush, it just flips back around. If I'm happy with that, we click apply. Okay, all right, so now what that's done is it's fixed it into location in terms of the Z axis. So I can't move it up and down, but I can still move it left, right, back and forward. So the next thing we need to do is constrain again, and this time we're going to use the same mate, but I might choose, say, the XZ plane, and I want that to line up with the XZ plane in the assembly. See this cutout here? I generally want that on the bottom, so if you want to flip that around to the other side, you can just click flush, and that'll turn that around, so that's on the bottom. So I'll apply that one, and then the last one we want to do is the YZ plane. Okay, so I'll click on that, and then I'll click on the YZ plane here, and it's going to be a flush one because the other one was flush. Click OK, and we're all good. Now you'll see I can't move that around, so if I'm clicking with my left mouse button and trying to drag, it's not moving because it is now fixed to the X, Y, and Z planes of the assembly. You'll notice if I select all of these up here and I'd select the same ones on my part, they are matching. And that's what we want to do, is always get that first one locked into place. That way we've got something to build off, and everything that we're going to build is going to be symmetrical to the assembly planes. From there, what we need to do is bring in the next part, which is the top cap. So we're going to click on place and then go down to the top cap, click open, and just pop that somewhere in your assembly. Right click, because it lets you put multiples in there, so just right click and OK, or you can press escape. Now from there we want this face to match on this face. We want to get this to flip over. Now you could use your free rotate button, and you'll see you'll be able to grab parts and turn them around and all sorts of stuff, but we don't really need to do that in this case. All we need to do is click constrain, and we're going to use our standard mate again. This is faces that are opposing, and we just click on this face here, and we want that to match with this face here. Now we want them separated, so if we pop back to our drawing, you'll see in here we have 30 millimeters between them. Okay, so what we're actually going to do, back in Inventor, if I can get back in there, we've got the offset, we're going to set that to 30 and then apply, and what that's done is it's offset those two planes 30 millimeters apart. Next thing we're going to do is use just again another normal mate, and we can mate this center. So if you just move over that surface there, you'll get the center line clicking up. So if we click on there and we do the same thing on the bottom, okay, it doesn't matter whether you get there or there, so I'm going to click there. That now lines them up so the center lines match. Okay, so we'll apply that one, and now the next step, there's a number of ways you can do this. You can either line the holes up, which is the way I'm going to do it, or you can use a flush mate and use the faces. It's up to you. I find the easiest way is just to pick one of these holes, grab the center of that one and the center of that one, and apply. Okay, and we're done. Now that one's fixed in place, so it knows it's 30 millimeters high. It's lined up centrally with this piece, and the holes are all lined up. So there we go, all good. Easy enough. Right, so from there we're going to put our first part from our content center. So we're actually going to stick the bearings in there. If we have a look at the drawing again, the bearings that we're using are SKF 2Z625. So 625 is the actual part number for the bearing. So if you ever go to CBC bearings or statewide or whatever like that, you can always ask for a 625 bearing and they'll give you the one that we're looking for. And this bearing has a 16 mil outside diameter with a 5 mil inside diameter. Right, so the way we do that is up to the place tab again. So we'll click on place, but click the pull down. This time we want from content center. So remember, normal place brings in your models that you've made. From content center we'll bring in models from the library. So clicking on there, this is going to load up this. So as you can see, I'll just close all this down. So this is generally how it opens all up, and you can see you've got fasteners, features, molds and bits and pieces. What we want is shaft parts, and then from shaft parts we're going to go to bearings, then we want ball bearings, then deep groove ball bearings, and if we scroll down, the one we're actually after is SKF 2Z with 2 shields. Click OK, and you'll see your bearing pops in there, but there's no given size at the moment. So the way we determine the size is, for the outside diameter, you need to move over the surface that it's actually going to mate to. So we click on that surface there, and then we click on the surface that it's going to sit on, so that bottom one there. Okay, then we click the tick. All right, now we're going to do the same thing for the top face. So surface, surface, tick. Right click, done. Alright, now notice when we put them in there, we've got a 16 mil diameter, but we don't know what the inside diameter is. Way we fix that up is just right click on one of them and go to change size. Then you can see we've got a 634, we wanted a 625. So if you look, 625 is the next one. Now if you're not sure of the part number, what you can do is click on the table view and then expand that out, And what you can see here, you've got the inside diameter and the outside diameter. So if you know those, you can say, okay, 16 mil is my outside diameter, 5 mil is the inside diameter, and that'll actually give you the part number. So once you've done that, because we have two of them that we want to change, we can click on this little button here, which is replace all, and click OK. And you'll see that inside changes. So there's our bearings, they're in there, and you'll see if you move in here and you click on the inner race and just move your mouse around, those bearings actually work. Okay, all good. Next section that we're going to do is make the body of the stepper motor. And this is going to be an in-context part. What that means is we're going to model the part within the assembly. So we're not actually going back to home and create part like we normally do. We're actually going to create this inside the assembly. It will still create a new part file, but we're going to be doing it in terms of inside the assembly, so we can reference all the geometry from these other parts, which is what makes it an in-context part. It's also going to be adaptive, and I'll explain that in a second. The way we do that, very simple. We just go and click on create. Okay, and then it comes up here, part name. So let's call this body. Again, you can call this whatever you like. You'll see it's going into our NEMA 17 project folder. So just click OK. Right. Once we've done that, we want to click on the surface that we want to start our part on, that we want to align it with. So I'm going to choose this one. Try not to choose all these, it's going to make it a bit tricky later on. So always put it on the surface that you want it to match up with. So we're going to be building off there. So I'll click on that one. Now you'll notice all your parts grey out. From there, what we're going to do is start a sketch, just like you would do with any normal part. Okay, and I'm going to click on the XY plane here. Now you can see all the geometry from the assembly, but it's all greyed out. Now what we're actually going to do is we're going to use some of this geometry quite easily. So I'm going to use project geometry. I'm going to make it construction geometry. And what I'm going to do is project that edge and this edge. Okay. Right. And that's really all I'm going to do. Or actually, while I'm at it, let's go and project. We want to project that edge, but we want this to be normal geometry. So I'm going to project these edges here. Okay. And we want to project the geometry that is the 3.5 mil hole. So when we think about this, that is our counter bore, and then this is the 3.5 mil hole. These ones here are all part of the threaded hole that we've got there, and well actually that one is the chamfer that we put on the outside. So this is the one that we want. So let's go and project that geometry. So this one. Okay, we're going to do the same on each one of these. Okay, there, and just over here as well. Okay, all good. Next thing that we want to do is just go and draw a rectangle. We're going to use 2-point center, and just click on here, just drag that out. Doesn't matter where you put it at this stage. Notice no measurements. The reason is because we're going to use this little button here. This is collinear constraint, and we're going to constrain this line with that projected geometry and this line with that projected geometry. Okay, and there we go. We have all the geometry now to produce the body. So from there, we're going to finish the sketch, and we're going to extrude. And for this one, we're going to click just on here. Okay, and under distance, instead of putting 30 millimeters, what we're actually going to do is going to click 2. Okay, you could put 30 in if you like, but I'm going to click 2, and I'm going to bring it up to this surface here. Okay, and then click OK. So that's popped all that geometry in there for me. So notice we didn't actually have to put any measurements in whatsoever. We were just using all the geometry from the top and the bottom caps, or in this case the bottom cap, which came from the derived part. So what that means is if we ever go and change that very first base part that we made in terms of the hole positions, sizes, all that sort of stuff, the octagon and all that sort of stuff, this body part will also change. All good. All right, so the next thing that we need to do, just having a look at our drawing, we'll notice this part. So this is a section A, so we're cutting through the body. There is a chamfer in here of 4.24 by 45, and it's got a radius of 3 typical. So what we'll do is go back to Inventor, and we're just going to do the chamfer tool. Okay, the size is going to be 4.24. Select these 4 edges, there and there. Click OK, and then we're going to put a fillet of 3mm on those edges. Turn around for this one, and there. Click OK. And then we'll assign a material. Okay, so this one's just going to be plain carbon steel. So you can just choose steel if you like. Okay, and you can choose a texture again. I'm just going to use a smooth black. Okay, smooth black normally looks pretty cool. Yeah, so that one there. And that is that part done. We can click on save, and we can go return. Okay, and there we go. So there is the bottom, the body, and the top. From there, what we can do is we can put in the bolts. Now, just one thing I should note, up here you got this little lightning bolt. That just means things need to be updated. So if we click on that, everything updates. So if you've changed parts and all that sort of stuff, if you click on that little button, the parts will show up and changed in your assembly. Now, the other thing to note as well, just notice you got these little recycle looking symbols just in here under the body. That just means that they are adaptive, so they are based off other geometry. So let's go and put the bolts in, and then all we need to do is make up the shaft, put all that together, and we are done. The way we do this, again, from placing from content center, we're actually going to go, this time, close shaft parts down, and we're going to go to fasteners. Then we want bolts, round head. Okay, and under round head we want this AS1427 metric. The one we're actually going to use is a Phillips head. Okay, so you can click on that one there, then click OK. Alright, so from here we want to come down and click on the thread underneath. That's going to make sure it chooses the correct thread size or bolt size, and then we're going to choose the surface that we want it to sit on. Now, because we have auto drop turned on, that will go and place it in the other 4 holes there automatically. If you turn that off, you'll see it only puts the 1 in. Okay, click the tick and right click, done. Now you'll see if I come down here, see how we can't see the bolt come through? So we don't know whether this is actually the right length. If you right click on one of those and go to change size, just like we did with the bearings, you'll see it's set to 16. Now we want 40mm, so we're going to choose that one, replace all, click OK, and that's now made them all the way down. Now they do go just down to there. Okay, so that's where they go. That leaves a little bit of thread so we can actually bolt this part to something else. All that's left now is to make the shaft. Now the shaft, you can do that as an in-context part if you like, or you can just make up a normal part. I'm just going to make a normal part. It's easy enough. So from there we go to the Home tab, click on Part, Start New Sketch, click on your face, okay, circle from the center, and this is going to be 5mm in diameter. Okay, and then we're going to finish the sketch. Then what we're going to do is just extrude that. Now you can be symmetrical about it and extrude it in both directions. And the measurement, do I have that in there? Not really. Let's just make it 66.5 for now. I think that's close enough. So 66.5, and click OK. I'm going to put some chamfers on the ends. So these are just going to be 0.5mm chamfers, just on there and on there. Click OK. Make sure you select the material. So this is going to be hardened steel, so high strength steel. And if you like, you can make it look a bit prettier by going chrome polished. Okay, so if we look at chrome polished, just makes it a little bit shinier. And save. Okay, and we're going to call that shaft. Click save, and you can close that. We'll go back to our assembly, and from here we're going to click place, and you're just going to bring your shaft in. Click open. Right, so there's our shaft. And what we want to do, we're going to use a slightly different constraint this time. Instead of using normal mate, and you can use normal mate where you can mate the center of the shaft to the center of the bearing and do a flush mate between the end of there and the bearing. But what we're going to do in this case is go to constrain, and we're actually going to use this one here called insert. This does a combination of both the center and the flush mate. As you can see here, it lines them up centrally, and you want this one here. If we go and just click on this edge, okay, and then we move over and click on this edge here of the bearing, you'll see that pops them in. Click OK, and there you go, all done. That is your completed stepper motor. So the last thing that we need to do now that we've got our completed stepper motor is just to go to the save button and click on file, save as, and you're going to give it a name and just call it stepper. You don't need to put the .iam in there, but that's the assembly file that it will create. I've already saved this one, so you'll see up here it'll come up with stepper.iam. Once you've saved that, the other thing that I wanted to mention was just quickly a pack and go. And what pack and go will do is it will take all the components from the content centers and any parts that you may have that are coming from different locations, and it will put it all together into one folder, which you can then zip up and upload to the cloud or email to whoever, whatever you'd like. This is fairly straightforward to do. All you need to do is just go and click on the File tab. Okay. Then go down to Save As, and we're going to choose Pack and Go. Once that happens, it will load up this little window here. Okay, and what we want to do is just up here, it's got all your source files and all that, and you can see here the destination folder. Okay, so you can pop this wherever you like. I'm just going to go and stick this maybe on the desktop for now. Okay, so I'll just come up and go to my desktop. And I'm actually going to create a new folder on the desktop. Okay, so let's go new folder, and I'm going to call this NEMA 17. Right, done, and click OK. Right, and you'll see it pops that folder in there. Once you've done that, you just need to click the search now. And what this is going to do is go through and find all the components, and it gives you all the locations of where it all is. And then we click Start. And what this will do is, well, it's done. So you just click Done once that's done. And that should create a folder. I'll just go and open that up. It's on my desktop. So I've just opened up the folder called NEMA 17. You'll see the stepper.ipj, that's the project folder. So when you want to load up this part, just double click on that folder. That will load up an instance of Inventor, and it will tell Inventor exactly where all the components are. Where you will find them is under Workspaces and then Workspace, and you'll see there's all your parts that you made. The Content Center files will be under Design Data, and yeah, all in here. So that's pretty much it for a pack and go. So all you need to do is take that folder, you can zip it up, email it, upload it, do whatever you like with it, and that will have all the stuff from Content Center plus all your models and bits and pieces all in one location. That's pretty much it for this tutorial. Hopefully you enjoyed it and you learned a little bit about making base parts, derived parts, in context parts, and assemblies.